This is Chrisferb, and I'm going to review how to perform a basic analysis of a control chart. They also call them a statistical process control chart. Now, normally if you do this and you're not just doing this to learn kind of the ins and outs of how this works, you would want to use a table to get a standardized standard deviation. Otherwise, what we're doing is we're using the standard deviation from the data. And so as the data becomes more dispersed, the standard deviation goes up, which means our control lines would broaden. And so it's essentially, we can't be using our data to create the standard deviation. You'd want to have a standardized standard deviation for it based on the sample size, and it's very similar to sampling distribution formulas. So I just wanted to get that out of the way just so you know. In the real world, you would use a standardized standard deviation for this. Okay, so this is part 2 of 2 videos on how to make a control chart in Excel. And so for this time, since we're going to be doing a little bit of analysis, what we have to do is add some granularity to our deviations from the mean, and so, or our control line. And so what we have to do is we have to go to make it easier on ourselves. We're going to go and actually make lines that are 1 standard deviation below, 2 below, and then a line that's 1 above and 2 above, and then our upper limit is 3 above the mean, and the lower limit is 3 below the mean. So all that I did was I added these 3 columns, and then I'm going to go and I'm going to copy over some of these pre-existing formulas and just change them just slightly as we go. Okay, so for the first one, I'm just going to go and pull them across. And so to make my life a little bit easier, I have I put in here an absolute reference, and I put the absolute reference in so that when I pull them across, the control line column doesn't get moved, and that's these dollar signs that I put in front of the D and in front of the 4. And so now I'm going to go and just pull this right across. And as I pull that across, it should look the same, which it does. But in this case, I just want to go and make it so that it's not 3 standard deviations below, but 2. And so I'm just going to change this to 2. Okay. And then I'm going to go and our formula is still looking good. We have I put the absolute, these dollar signs in here. So now I'm going to go and I'm going to do it one more time. And I want to change this now to 1, and technically I know I could take out the 1, just not have a 1 in there at all, but because I'm going to be multiplying by 2 coming up, I'm just going to keep the same structure in there. And so now it's 17, and then I'm going to go and do it one more time. And in this case, this is going to be plus 1, or 1 standard deviation above. And so in this case, what we're going to be changing is the negative to a positive. So that'll give us the 1 above. Oh, I accidentally changed the wrong one. This happens to me sometimes when I'm pulling these across. Okay, enter, and this one needs to be positive. Okay. Okay. And now we're just going to pull this last one over here, and it's going to be the standard deviation multiplied by 2. And so make sure I click on the right one there. Multiplied by 2. Okay. And then our upper, which is 3 standard deviations, is 68. And if everything looks right, then the lower is going to be the lowest one, which is 3 standard deviations, and it goes up. And the control line would be somewhere right in the middle, which is correct. You could always take the control line and move it, but then I'd have to change all my formulas, so I'm not going to do that. I'm going to do autofill and just pull these down. That gives us the straight lines on the control chart when we make it. And pull them all down. Okay. So you already made a control chart in the first video, but if you were to make a control chart, you just do this. you would select all the data and the header, and then you go to Insert, and then you do recommended charts. But in this case, it's kind of recommends one that's a little funny. So because there's so many lines, and I don't want this weird like origin deal where the lines come from, which is right there at 0. I'm going to go to all chart. I'm actually going to cancel out this, and I'm going to do I'm going to pick the line charts, and I think one of these, yes, this one looks fine. It'll show you that little pre thing. It should look like it should have those straight lines in there because those are all of our columns that have the same data. And so I would just click on that. Now I believe I already have my my control chart already made on these other pages. Let's see. Yes. So these are the control charts from the data. So you would just input your you would go and create that chart, and then you can put it on. I put the chart on these different pages. So this is the control chart, and the control line is this orange one right here. That's the center. That's the mean, and then as it goes out 1 standard deviation for each row. And so that little gray line, they don't need to be in there, but it's these dotted ones. So this is 3 standard deviations below. That's the lower limit. This is 2 below, 1 below the control line, and then 1 above, 2 above, 3 above. Okay. So now there's 5. There's actually more. You can go into this quite a bit, but I've chosen 5 common factors to discern whether you have a process that's in control or not. And so that's the big thing we're looking at. Right here on sheet 1, I have some notes on this. So when we're using control charts, we're interested on whether a process is out of control. So if there is an assignable cause to the variability, then we say the process is out of control. So assignable cause means we can pinpoint what the cause is. You say, oh, well, that was because let's say you're using machine dies, for cutting metal or something, for turning things or whatever, and you go, that one was a damaged die that was used, so the tolerances on all of the things that were made, the items that were made during that shift, were out of tolerance. So that's an assignable cause. Now, when it's not assignable, there's inherent variability, and that's where there's variability built into just making things and processes, moving parts. And it's not because of excessive wear. It's not because somebody did something wrong. It's inherent variability, and that's normal. And so what we're looking for with control charts is assignable cause of variability, which means it's out of control or unstable. Okay, so that's what this is all about. So I'm going to go back to, here's chart 1, and this is the first one that we're going to be looking at. Any point outside the control limits, aka upper or lower lines. So in this case, this factor that we're looking for is any points that are outside of 3 below the standard deviation or 3 above the standard deviation. 3 standard deviations above the control line or 3 standard deviations below the control line. And in this case, we don't. I'm going to skip to the answer here, but you can probably you could tell early on that we do not have any points that are outside of the upper and lower control line. So if we did, then that would be very suspicious, and we would say that the process, there must be something that happened that day specifically, or happened to that, say, sample of data where it's obviously something's out of control. And so for the second one, 2 or 3 consecutive points past 2 standard deviations. So this is our control line right there, and this is this blue one right here. This is 2 standard deviations past the control line right here, and this is 2 standard deviations down below, this orange one, below the control line. And so we don't have any points that are past the lower, And for the upper, all that we have is, let's see, we have one point that's sort of maybe slightly above it, and then another one that's slightly above it. It says 2 or 3 consecutive points past 2 standard deviations. So we do have 2 points, but they're not consecutive because this one is below. So for this one, this rule doesn't apply as well. So it's still an in-control process. Okay, so for this one, 4 or 5 consecutive points past 1 standard deviation and on the same side of the center line. So 4 or 5 consecutive points past 1 standard deviation. And so in this case, this is a control line, and then we're looking for 4 or 5 consecutive points past 1 standard deviation on the same side. So this is the 1 standard deviation above, and this is 1 standard deviation below. So in this case, we have 3 right here that are passed, but we're looking for 4 or 5, so that doesn't count. This one isn't consecutive. That's not consecutive. They both go across. And then for this one, we don't have any that, I'm sorry, it's the blue one. 1 standard deviation. So in this case, we do have 3 points, and we actually need to have 4, and they're not consecutive because they go back. So this one's another. This rule doesn't apply to the data. And then number 4, 7 consecutive points above or below the center line. So in this case, we're looking for this whole shift, or like a drift of somehow the control, or the actual measurements, or the quality of whatever we're making, like drifted to the point where it's continually being below or above. And so when we look at this one, it says 7 consecutive points above or below. And so this is our center line. And so we're looking for 7 consecutive. So there's not 7 consecutive above for sure, because they keep dropping back. So below, let's see, we have 1, 2, 3, 4, 5, 6, almost 7, but it pops up over the line. So once again, and then this one, 1, 2, 3, 4, but it pops up, and then like 2 or so. But this point right here makes it so that the process is still technically in control with these rules. It may be just because it's still technically in control, you might want to look at some of these things, or scratch your head, like what happened that day, if these are different samplings. But still, in this case, it doesn't apply to this rule doesn't apply to our data so far. So then let's look at number 5. 5 consecutive steps up or down from the center line. So in this case, you have to have, it's like stepping down or stepping up 5 consecutive times. So we don't have, it'd be like stepping, like continual going down. It's not just the counting of the ones that go up and down. And so this one, once again, this is doesn't apply as well. So I made up this data randomly. I mixed it all up, and I wish I would have had 1 or 2 more in there, but I picked the data before I put together this second video, so it is what it is. So if you're ever interested in this, what you want to do is you want to search for statistical process control, and there's a lot of data out there in the internet. There are other rules as well, and I believe it's Western Electric in the 30s made they have a manual that's about 300 pages on this whole thing. And so you can really go into the weeds, but the reason why I made these videos is because it's a good, I wanted to do a basic introduction on how to make a control chart. And once again, as I mentioned before, if you're doing this in real life, you would want to find a standardized standard deviation. Otherwise, that standard deviation in your upper and lower limits would be changing as your data becomes more distributed, or more diverse in its spread. And so that would be an issue in real life. So thank you.